Good morning, everyone, and a warm welcome you all for joining us today, whether you are tuning in from India or across the world. As a part of World Space Week 2025, with the inspiring theme this year, Living in Space, we are delighted to bring you yet another exciting session that explores the wonders of our universe. Today, we have with us a brilliant young mind in modern cosmology and theoretical physics, Shri Om Trivedi. His pioneering work spans cosmic inflation, dark matter, dark energy, and interstellar objects. He is also part of the Galileo project at Harvard and has made significant contribution to our understanding of the universe. The title of his talk today is What's Happening Around Us, Interstellar Object and Beyond. Sri Om Trivedi will take us to a journey through some of the most fascinating astronomical discovery of our times, from the first interstellar visitor to the recent discovery of Three-Eye Atlas, and explore their implication in science, civilization, and the search of life beyond Earth. We are truly honored to have him with us today. Without further ado, let's welcome Om Trivedi to begin the talk.
Yes, thank you so much, ma'am. It's an honor, and I would like to thank you and also Rishabh for the invite. Uh, I have always heard about the like the amazing things the Nehru Planetarium has done for science and for science communication in India, and of course, in particular for astronomy. And I cannot be more excited and more grateful to like get a chance and to be invited to to give a talk. At least of course, I am not in India right now, and so of course, I could not give it in person, but like at least through this web seminar method to give it for the planetarium. So it's my deepest honor, and thank you so much for this.
It's absolutely our pleasure to host you, sir. Thank you.
All right. So with that, should I start screen
Yes,
sharing?
yes, please. Yes, please
All
start
right.
the screen share.
Thanks so much. All right. So let's get started, and let me just make sure that everything is working fine. Right. So just to be clear, I hope my screen is visible.
Yes, it's visible.
All right. Thanks so much. Right. So hello and welcome everyone. So as Reena ma'am mentioned, today I will be talking about interstellar objects. And why should we care about such objects? What are these objects? Could they tell us something about the theme of the Space Week this time, which is life in space? And are these objects just merely fascinations of our imagination, or do they hold something very deep within them, which we should really seriously try to uncover? So I will be basing this talk not on a very deep uh, you know uh, like this will not be like a very deep technical talk. So people from like all facets of life can really understand what I'm trying to say. So it's not just for like people who write research papers and stuff like that. But at the same time, it will be very extensive. So we will be discussing various facets of these interstellar objects, and we will try to at least in the 1 hour or so that I have, I will try to uncover as many paradigms of these interstellar objects as I could, and I hope that you guys find it interesting. uh, as I mentioned, my talk will also feature some of the recent works that I have done with Professor Avi Loeb from Harvard on this. He is my co-advisor and perhaps the most well-known voice in the world on interstellar objects today. And to some of the audience of yours who must have tuned in, if you are interested in interstellar objects, if you are interested in like planetary astronomy, you would have definitely known about him, or like at least heard about him somewhere, on Instagram, on on your news feed, or like somewhere. So yeah, I will discuss some tiny bits of work that I have done with him as well. Of course, again, we will not go into the very deep technical details of those works, but yeah, it will be interesting. I can assure you of that. So without any delay, let's get started. So, firstly, what are these interstellar objects? What are these visitors, and why should we care about them? So let's recap. Let's go 2000 years back. So you know now today we are I am giving a talk at the Nehru Planetarium, and so this becomes important to not only talk about the people from the West who have been doing astronomy, or at least trying to see the stars some 2000 years back. So your usual suspects, people like the Greeks, but also in India as well. Astronomy has always been something which has been very deep rooted. So we have always been very much fascinated with the movement of the solar system. In fact, the Indian society had long known about the centrality of the sun, long before the Western people ever did. And so we have been astronomy nerds for the longest amount of time, and that has not changed a lot in the recent years as well. And so for centuries our hope and our focus with astronomy, with with the stars, or with the celestial bodies as it was called long back, was focused on what we could see in our solar system. And that was pretty understandable, because you could possibly, on a good night sky, you could possibly see some planets. But that was the best you could do, right? You cannot, with your eyes, even though the night sky might be the most brightest, you wouldn't be able to see some random star which is, let's say, 500 light years away from your planet. Because you could possibly see that by chance on some random day. But if you want to observe something, if you want to really scientifically, or at least technically, logically, try to assert some physical properties of these objects, then you have to keep on observing such objects for a long time. And of course, without modern technology, that wasn't in our menu at that time. So for most parts of human history, our focus was only about objects that we could see in our own solar system. Again, coming back to the Indian stories, and some could argue that some of the ancient Indian scriptures have been mentioning about multiple galaxies, at least for the longest time. So we have been thinking about these things longer, and possibly in a more generalized way than most people have ever done. So yeah, that was the tiny bit of history that I wanted to cover. After that, now something interesting happened in 2017. So till 2017, by the time that we reached that particular year, we had the advent of the new age of astronomy. We had very huge telescopes everywhere in the world. You had huge gravitational wave observatories. If you remember, this was around the time gravitational waves were experimentally verified by physicists. And so the late 2010s were a very good age for doing practical astronomy. And so at that time, all our premonitions about the solar system and the objects within it changed completely. Because at the time, we were introduced for the first time to stuff like the interstellar objects. And what does this word really means? So interstellar objects are basically objects which have been traveling between stars. So our whole solar system is basically just one reasonably massive star around which some planets keep on revolving. And as you might guess, we are not very unique. There are multiple systems like this, star systems across the universe. We have observed millions of such systems, right? And of course, you can then imagine that as asteroids, as comets travel inside our solar system, it could be a possibility that given other star systems, such pieces of interstellar rock, these objects that keep on randomly moving between stars, could certainly be moving between us as well. But that was in 2017. It was the first time that we were able to definitively say that there was some object. which came from a different star system. That was a big thing. Now, what was this object? Now, these have been the three big objects, the three real interstellar visitors that we have identified so far. In October 2017, as I mentioned, we found out something known as Oumuamua. Technically, the word here is one eye Oumuamua. One eye meaning the first interstellar object, and Oumuamua being the name. Oumuamua, the name really came from the from a Hawaiian folklore, because its discovery was very much related to Hawaii. Then you had in 2019 you had a second interstellar object. Well, just between the space of 2 years, you discovered the second interstellar object in the history of mankind, and that was Borisov. Technically speaking, the name was 2I Borisov, so the second interstellar object. Then came a gap of 6 years, and as you note, this is something very recent. So in July 2025, in a very recent paper by a physicist named Seligman and his team, they were able to identify a third interstellar object, which they named as Atlas. Again, the technical name is 3I Atlas, which means the third interstellar object, and the name of that object is Atlas. Now, you would note that I have displayed Borisov in a different way and Oumuamua and Atlas in a different way. Why have I done that? And is there any particular reason for that? The reason for that is very important and of course very significant. So, when we observed Oumuamua, we were actually very surprised because first things first, it was moving very fast. I mean, we know that, in space, asteroids, comets, they move fast. But this object was moving alarmingly fast. And so you could not compare the speed of this object, the acceleration of this object, with stuff like comets and asteroids. And so that was the first clue that we had that, something was off, and possibly there was something which we could not explain definitively. Uh, the other thing was it was fast and it was big, so it had a very elongated shape. And The other part was that you cannot explain its acceleration simply due to natural causes. So what happens is when you talk about intergalactic travel, when you talk about objects which are moving inside a galaxy, you usually think that the acceleration or the movement of such objects is purely due to the gravitational force that is being exerted on such objects due to the other big objects around them. So imagine that you had some kind of an asteroid. So let's say when we say that an asteroid is arriving towards the Earth at a very fast speed, why do you think it was on that speed to begin with? Well, in general, such objects are created because of some kind of cosmic mishap. So, for example, there, there could have been some collisions between stars. There could have been some kind of a collisions between planets as well. And because of that kind of a cataclysmic event, you get these remnants of huge rocks which get glittered across space. But as they're moving through space, the only force that could be exerted on them is gravity. And where does that gravity come from? Well, that can come from other stars, that can come from other planets, big planets, that can come from other moons of the other planets. And so what we usually assume when we try to do such studies is that the acceleration or the speed of such objects could be explained completely by the random movement of gravitational forces around them. But if we ever find out that you cannot explain the acceleration of any such object using just your random approach, then of course there is something which is happening over there that we cannot explain using just our simple physics. And You need to realize the gravitational force is literally the only force, at least astrophysically speaking, on these levels, that should be acting on such objects. So, like, if there is any other thing which is accelerating such objects, well, that could be some kind of artificial thing, right? And so, when Oumuamua was discovered, some called it like a natural fragment. Some people tried to prove that it was just a comet, that it was just an asteroid. While others, including my co-advisor, Professor Avi Loeb, suggested strongly that it was not the natural object that we think of it at the time. At least it was not as natural as an object as you could think of, in terms of at least comets or asteroids. So there was something happening over there. Then in 2019, we found out about Borisov. This was the second interstellar visitor, but the thing was that in this case, well, it was very quickly proved that it was just a comet, right? There were various research papers which definitively proved that it was a comet, because unlike Oumuamua, it behaved like a typical comet. It had the properties of a comet, and so what it went to and so what it went to tell us is it is not really important to assume that every interstellar object that we would ever encounter would always have some kind of mysterious origin. In general, it could also be that some misguided comets, some misguided asteroids from other stellar systems might just come to our solar system for a visit. uh, then in 2025, we found out the 3A atlas. And again, now I will tell you the reason why I depicted Borisov in this manner and these two people in this manner. Because Atlas is the largest interstellar object we have ever observed. It is very large. And at the same time, it is very, very, very fast. It is fastest, and it is the largest object that we have ever observed. So it is moving at speeds around 58 kilometers per second. Again, I would give you one moment to realize how insane that is. 58 kilometers per second, right? So this object completes 1 kilometer in the 58th part of a second. That's very fast. And if I were to tell you, one of the recent papers on 3A Atlas suggested that its mass could be, and hold on to your hats, 33 billion tons. 33 billion tons. Its radius can be around 5 kilometers. So it could be around 10 kilometers in length in its whole diameter, while some other papers have even suggested it to be as large as 20 kilometers in radius. That's like that's like a big town moving through space at a huge velocity with a 33 billion tons of mass. And that's why people think that similar to Oumuamua, you cannot explain 3I Atlas using just some kind of a typical comet, typical asteroid behavior. You need to think of something different. And so, in general, what should we expect of interstellar objects, or what does our math, our physics math, uh, allows us to expect from such objects? Well, in general, we move with the assumption that such objects should be asteroids or comets that come from outside of our solar system. They may have been ejected from other planetary systems long ago. So as I mentioned, such objects might be the result of some cataclysmic event near our solar system. And as they are traveling through our galaxy, they eventually pass by our sun. So it's not really like deliberate that one such object is coming towards the sun. I know they might have crossed many such stars, not only our sun, and their high speeds make them distinct from local asteroids. So uh, asteroids don't move that quick, right? But still, there are always certain features which which make even some objects very much stand out even in this category. So why would such ISOs be important? Well, firstly, we are always interested in trying to understand, like, molecular structures in other worlds. So, if you know, there is something known as space mining, which is which will possibly be some kind of a business field in like the next 50 years. So, like, if somebody in the audience wants to do, wants to have some kind of a, first hand experience of, like, being first in line for like some kind of business, you might want to consider space mining if you have the money. So, there's this idea that you can actually, send mining missions to the moon and get your favorite raw materials from the moon, instead of, excavating such stuff on the earth. So basically, we want to do business on the moon as well, right? And and I think some countries are trying to do that already, and they are trying to build missions for that. And while it may sound expansionist, and I will come back to this later on, which will make you realize something. While it may sound expansionist, it might be the need for us, because if you realize, some of the wars, some of the conflicts that are happening on this planet right now are only and only because of the fact that, like, there are some raw materials that one country wants from the other country, and so for that reason, they have to fight it out. But if you had another random planet from which you can very easily extract out stuff, well, why wouldn't you want that? So, for a similar reason, we want to really understand what kind of a raw material, what kind of, raw stuff we can get from other star systems. So, 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 so that tells you why ISOs can be important, because by studying the the luminosity patterns, by studying what kind of radiation the interstellar objects are trying to reflect from themselves, you can possibly try to understand their molecular composition as well, and that becomes something which is very interesting. Furthermore, uh, there could be, reasons to believe that, some of these could also carry organic compounds. Well, sometimes, like, there is one theory which says that, like, the reason, we have, like, the current biotic life on this planet was because long back, some asteroid hit the planet, even before dinosaurs were there, and it went towards our water bodies, and that gave life to the aquatic creatures, because, we all of us came from some organic compounds on some random asteroid which decided to hit the earth on some fine day. That's a theory. So, it could be possible that, such interstellar objects might also carry some kind of organic or prebiotic material. That can be something interesting. And so this makes these objects very interesting. And how do we detect them? So again, as I mentioned at the start of the talk, for the longest time, we did not have the capability, we did not have any kind of measure to actually detect such objects, because in आप अपनी आंखों से देख के आप कितना ही बता दोगे कि भाई कोई सा स्टार कितना ही दूर है, right? So now, we have huge surveys, we have huge missions, we have huge observatories dedicated to scanning the sky every night. And the best part is, we are not only having, some kind of a astronomer just sitting below a telescope trying to observe something, but at the same time, we have a amalgamation of both astronomers and computer science people. People who are trying to use the capabilities of computers to their max capacities in trying to understand the data that we get from these surveys. Remember, we are not just observing something. It's not like, we observe some dot in the sky, and we just say, oh, at this point there is a star, at this point there is a planet. That's not how things work. In astronomy, in astrophysics, in cosmology, we work with data, and we try to figure out what the data set is telling us about the existence of some celestial body somewhere in space. And so, whenever you have data, you want to analyze that data to your best capacities, and for analyzing the data, well, perhaps your best mate is a computer. And so, stuff like machine learning, neural networks, all of these are being readily imported into the pipelines for astronomy these days. And these have become very ubiquitous, ingredients of us trying to understand really, how things are working out in planetary astronomy. So that's something which is very, very interesting, and very important at the same time. So, what do we learn from their paths? What kind of physics can we actually make out from their paths, and what kind of stuff can we actually understand, from these objects? So their orbits and speeds tell us about how common such visitors should be. Technically, there is something known as the encounter rate. So the encounter rate is basically, as the name suggests, it tells you how frequently you could possibly encounter such an object. So given that you know about the you know about this object's orbit and its speed, you can possibly make out how common would it be to ever observe such a visitor. And from that, you can tell a lot about such objects. Like, for example, Oumuamua's speed suggested that it came from a constellation which is known as the Lyra constellation. However, in the case of Borisov, it came out that it might have originated from a different galaxy altogether. So, there are whole host of things that, that you can see in this regard. And their trajectories also tell us whether that object was deflected towards the solar system by some other planetary body or some other celestial system. Or it can also be that our own solar system captures such objects. Now you might ask, how can a solar system capture one object? Well, it's not that solar systems capture only one object. Rather, the thing is that a solar system has its own collective gravitational pull as well. So let's say a random interstellar object is just moving through space. So it could be deflected towards our solar system because of its own gravitational pull as well. So their trajectories, their speeds, their positions, their orbits tell you whether the object came into the solar system because of deflection by someone else or by our own solar system, right? Now, how can we, think about the future in this regard? So, you might say that, in the last 8 years from 2017, we have discovered three objects. Well, that's a very, small rate. Well, that is certainly true. But then I will tell you that till 2017 we had also only discovered about a few black hole mergers, right? We had only discovered a few gravitational wave events. However, uh, at the time of my speaking here, we have observed hundreds of such events now. We have observed gravitational wave events across the universe at this point. It's not something which is very unique now. And why do I bring that up? I bring that up because, with the advent of better technology for gravitational waves, with the advent of better resources for gravitational wave astronomy, we were able to detect hundreds and hundreds of such events. So, similarly, there is one very ambitious observatory which is coming up. It is being made in Chile. Almost, I mean, I am a part of a collaboration which works on the commissioning of this observatory. And I mean, people already work there, but like it's not really taking data right now, for the ISOs at least. And so in the upcoming years, we will expect that possibly the Rubin Observatory in Chile will give us hundreds of ISOs. And that is per decade. So it can perfectly be true that there are some ISOs that we have just missed out on the last 8 years. It can perfectly be true that there were just some interstellar objects which completely evaded us because we didn't have the capacity for them. All right. Already, stuff like the 3I Atlas tests our understanding of these objects on the very extreme level. Because like if there was an object which was even faster than the 3I Atlas, we might not have even detected it, given our given our current technological capacities. So of course, it can be true that Oumuamua, Atlas, and Borisov are not the only objects that have been moving in our solar system, coming from some other star system. But yeah, these were the three that we were able to detect given our best capacities. But yeah, the Rubin Observatory will possibly help us in that regard. And also there are certain ideas these days to actually catch uh, an interstellar object. Of course, that is something which is, I I think that is quite far in the future, but like there are theoretical works these days which which are being done towards the idea of of like intercepting such objects. So like basically making satellites, making missions across the earth, where after the detection of a particular interstellar object, you can possibly just aim your satellite towards that object and just try to hit it with something. Now you might ask, why would it be helpful? Well, because firstly, you can possibly attach a camera to an interstellar object. Well, that could be something which is very interesting. You will understand about its molecular composition. You will possibly understand about where it came from as well, and you will get real time exact data for that. So yeah, that is something interesting. And the other part is, if an object like that was headed towards the earth, that will cause destruction on the largest levels. And so it might be possible that in the future, if one such object is coming towards the earth, we would have to intercept it, not because of our curiosity, but because we want to exist, right? We don't want our civilization to end. So why this matters to everyone? Because they may carry clues about the origins of life, right? Because as I mentioned, one such theory about the origin of life on this planet is related to such interstellar objects hitting the earth long back before we existed. It also tells us that the solar system is not isolated at all. We are part of a big galaxy. And it could also give us clues towards interstellar exploration, because eventually humanity aims to become a civilization which is not just focused on the seven continents that it has been given naturally on this planet. It is a civilization that wants to explore, in the deepest of sense of that word, the whole universe. And so possibly studying such objects can help us understand how we can better interstellar travel as well. Someday possibly it could happen that one such mission of ours could be going towards some other solar system, right? Like the Voyager spacecraft, which was sent long back by NASA, and we lost contact with that spacecraft long back as well. I mean, I think it was a little after it went, you know, like even beyond Jupiter, that we lost contact with that. So yeah, uh, you know, it can help us make even better interstellar objects ourselves. But now, on that point of Voyager, I come to something which is very interesting. Now, imagine this: you are some other civilization, and you know, uh, the Voyager spacecraft has been in space for almost 50 years now. Who knows where it may be now, right? Of course, like asteroids, like comets, we would assume that the Voyager spacecraft is being deflected because of the gravity of various other celestial bodies at the time. But imagine that you are like some alien civilization, and you detected that aircraft at some distance from your solar system. Well, your first reaction to it would be, well, that's a comet, that's an asteroid, right? Because you want to be scientifically true. You do not want to make up hoax theories. But now you know. That Voyager was not a space was not an asteroid. That was a design thing, which was designed by humans to explore life across the universe. So, what gives us in not admitting to a possibility that the interstellar objects that we observed, which are moving at anomalously fast speeds, and some of them are very, very, very huge. It could be possible that those might be the Voyager spacecrafts of some other civilization. Why could not that be a possibility? That can certainly be true as well, right? So you know now I come to the point of Oumuamua, because I think for anyone who has been following the news on like astronomy or like planetary astronomy in general for the last 5 years has definitely heard about the, uh, the possibility that Oumuamua might have been artificial, because for instance it showed a small but a clear push away from the sun, right? So it was as if it was engineered to not really hit the sun, and that's something which is very interesting. uh, you know a lot of people debated whether it was just a uh, natural bully of rocks, or perhaps it was a thin artificial object. It was again something which was strongly advocated by Professor Avi Loeb at the time. And eventually, there is no one consensus as to whether or not Oumuamua was truly a technological object, or was it just some very, very, very random but at the same time very lucky event that we observed. Because something that huge and that fast is something which should be very unlikely to occur for us. And so people have always been advocating about whether or not Oumuamua was something which was created by someone to go towards the solar system. Why? To hit us, to probe about us, to destroy us. Well, you can ask the question as to why you made the Voyager spacecraft, and possibly somebody made their own version of the Voyager spacecraft long time back, and sent it towards us, or possibly they lost contact with Oumuamua as well. So it can be something like that. And what if uh, for sure, let's say, if we think about the possibility that such objects were really made by some other civilizations, then it could be possible that such civilizations could also leave some kind of techno signature. Now, what is a techno signature? Well, a techno signature is literally what the words suggests: technological signatures on some kind of a spacecraft, on some kind of a stellar object. And so by techno signatures, what I really mean is, in general, what you assume with asteroids, with comets, is they have a particular type of radiative capacity, right? So they radiate light from the sun in a natural way. Now that natural way is something which is understood using the Stefan Boltzmann law. I mean, for the people who are interested in the physics of this stuff, right? But uh, if it deviates from the natural approximation, from the natural understanding of that radiation of light from the sun, well, then we can actually measure such things. We can actually get a hang of such things using our data, using the stuff that Rubin provides us, that Pan-STARRS provides us, that the other observatories that we have provides us. And so why would it radiate in a different way than what we expect naturally? Well, that could be something which tells us about whether it was technologically made, or whether it was engineered towards us in some way. And so technosignature research can be you know basically developed very strongly. In fact, it has been developing quite strongly in the last 5 years because of Oumuamua. And so this can be like a very new subfield, which like possibly somebody from our audience, or like some people from our audience may work for their PhDs if they really want to do a PhD. And so and so technosignatures could, if you find definitive technosignatures, let me just tell you this: if you find definitive technosignatures on some object, and if you were to make like a consensus of the whole physics community that those technosignatures are indeed true, well, you have a Nobel Prize in your hands. Well, recently the Nobel Prize was given for quantum tunneling and stuff like that. Well, you can even get a Nobel Prize for this, because you understand, if you can prove the existence of technosignatures on some object in space, well, you are effectively proving the existence of life away from space. Now, whether that Nobel Prize will be for physics, or for biology, well, that's upon you to decide. So how can we check? As I mentioned, we can check their shape, we can check their brightness, we can check how they move under sunlight. And future telescopes, or so some of the missions that we have are, I mean, we don't only observe stuff in space using ground-based telescopes or ground-based observatories. We used to have the Hubble Space Telescope, which was basically, as the name suggests, it was like a spacecraft which was mounted with a huge telescope, and that was in orbit around the Earth, and it was observing everything around us. And now we have its replacement, which is the James Webb Space Telescope. So possibly space based telescopes and ground based telescopes, observatories, all of them can work in some synergy to uh, tell us about the composition of such objects in detail, as and when the detection of such objects keeps on increasing with time. And of course, as I mentioned to you, a planned mission might one day also intercept an ISO. And if you want to be ultra ambitious, well, it could be possible that we intercept an ISO and take it back to our planet as well. Well, but I'm not sure whether such kind of a technologies, or like such kind of a mission would be realized in any of our lifetimes. But yeah, that's a very savvy possibility as well. And so one might ask, well, this is not really science, right? You might say that this is just some kind of a philosophy. You're just trying to debate whether life exists in the universe. And I would like to really disagree with that. This is hardcore science, and this is possibly the most deepest science you could you could think. Because I mean, imagine, why are you trying to understand astronomy? Imagine, why are you trying to understand cosmology? Imagine, why are you even trying to understand the universe? Because one fine day you were at the balcony of your house when you were 3 years old, or one fine day you were at the terrace of your house when you were 3 years old, and you looked up at the stars, and you asked the question to your parents, or like to like yourself, well, why do these stars keep on blinking? You asked a question as to why the moon was the way it was, why the sun was yellow or like gold, or like whatever you want to say, why the moon was white, why sky becomes dark in night, why it becomes blue in the day. You asked these questions because you wanted to understand why you were here in the first place, right? Our deepest questions in theoretical physics, whether it is about string theory, or whether it is about dark matter, dark energy, black holes, Big Bang, everything, I have worked on that stuff as well. That is also my field of research, and so I can really tell you that all of those questions, fundamentally are because of only one reason, and that is because we want to ask one question and answer that question very well. And that question is, why are we here, and why is life the way it is, right? And I think that question typifies the whole of science in general. And so if you can take that question to the next level, and possibly ask why life is there in the other planets. Well, that is next level stuff, because now you're not only trying to understand the universe for yourselves, you're trying to understand the universe for whatever the other people are there in the universe. And it tells you one thing which is very interesting, because if we are isolated in this world, well, then that throws up quite some questions, because, well, was this world only made for us? Why, in a very isolated solar system, in a very average galaxy, we have like an average star which is a sun for us, right? And we know that there are millions of stars bigger than this sun. We know that there are numerous galaxies which are bigger than ours. We know that some fine day, like if there was a black hole very close to us, we could have died a long back as well. So, and we are always exposed to meteor showers and stuff like that, but we have like a very interesting magnetic field across the earth which saves us from such stuff. And so that gives you a question to think about: was life engineered for humans to exist? You go down a rabbit hole of such questions, if and when you never find out that there are other living beings in the universe as well. So it basically cuts off a huge amount of questions. Of course, it gives you new questions to think about, but it at least answers you one very important question. Well, that you are not unique. Humans are not someone alone, and there are other people in the universe as well. And so, asking such questions about interstellar objects, asking whether or not they are technological or artificial, is not just something philosophical. It tries to dig deep into the fundamental question every student, every person, every every person out there interested in science really wants to know. And that question is, why are we here, and why is life the way it is? So it hits very deeply into that. Now let's go into some other line, because if if some of the interstellar objects are indeed made by civilizations, what kind of a civilization really gave us such objects? So in 1964, astronomer Nikolai Kardashev from Russia proposed a way to actually classify these civilizations, and he gave out a very simple way to actually understand it. So so his idea was, in order for a civilization to be strong, in order for a civilization to be dominant, it needs to have a lot of energy. It needs to have a lot of power in its control. Of course, that is very understandable. If you want to be strong, you need to have energy. ठीक है ना? भाई, अगर आपको शक्ति चाहिए, या फिर अगर आपको महान बनना है तो आपको शक्ति चाहिए. So that was similarly what he was trying to say. So then he gave three levels of such civilizations. So type 1. So in this case, the civilization is strong enough to harness all the energy available on its home planet. So basically, it is a master of its planet. It reigns supreme over every other living being on that planet. Then there is type 2. In that case, the civilization can use all the energy of its home star. So basically, it can use all the energy of its version of sun. And then there is type 3, which in the Kardashev scale is the strongest type of civilization. And that is the civilization which can use all the energy of its galaxy. So basically, it can dominate its complete galaxy. And do you realize how big that is? I mean, one galaxy has like millions of solar systems. So a type 3 civilization effectively controls the fate of the whole galaxy. It's like a government for the whole galaxy. So that's huge. So you can imagine the amount of resources such a civilization might have. Where are the humans, right? Well, we reign supreme over the other living beings on our planet, for sure. But do we have all the energy available on our planet, on our disposal? Well, you might say that we also take energy from our home star using solar energy, of course, but that is like a very very small amount of energy out of the total potential of the sun. So we don't belong to the type 2 civilization, of course. Do we belong to the type 1 civilization? Sadly not, because, for example, we have never explored the, like the full extent of the oceans. We have not went, completely deep into all the oceans that we know of on this planet. There are some regions of Antarctica that we still have not explored. There are some very non-trivial ways of making energy, like nuclear fusion, that we don't really understand how to do. So we know that there are various avenues from which we can extract more energy that we have not even succeeded of doing on this planet itself. And so, in Kardashev's scale, humanity is type 0.7. So it is a civilization which indeed is the strongest on its planet, but really, still cannot take the full advantage of its own planet. Then, I'm pretty sure a lot of people who came into science, who came interested into astronomy, were inspired by this man over here, Carl Sagan. So Carl Sagan, refined this scale because Kardashev only gave, like, some kind of a qualitative scaling. He just described type 1, type 2, type 3, but he did not give any particular mathematical relation. In physics, in science, we really like to, associate ideas with mathematics, and so you need some equations sometimes. And so, Carl Sagan proposed this equation. So basically, this is like the Kardashev scale of the civilization, and this is the power that that particular civilization can generate in its full extent. So now, using the maximum amount of power that a civilization can generate in watts, you can then correlate that with the Kardashev scale of that civilization. All right. So basically, this means that a civilization's level increases very smoothly as its energy use increases. So, and it gives you like a very good, simple way to, mathematically map out the Kardashev scale with the total power output uh, of the civilization. So, and the best part is, well, this is consistent with Kardashev's scaling for humans, because humanity, using this equation, is very close to 0.7, and so that's fine. Now, so the Kardashev scale was based on understanding, civilizations. But then recently, with the idea that interstellar objects might be, coming because of some kind of artificial or intelligent origin, Professor Loeb, Professor Avi Loeb suggested the Loeb scale, uh, to to classify such objects similarly as the Kardashev scale, but only for particular objects, not for like a whole civilization. And this scaling is actually more involved than the Kardashev scale, because the Kardashev scale only had three types, while here we have, types 0 to type 10. And here, the the low levels on the Loeb scale basically mean natural behavior. So basically, you can explain such, objects which are like, close to 0, close to 1, close to 2 on the Loeb scale, to just be, natural objects, with like some anomalies maybe. So for example, Borisov uh, was classified as a level 0 object on the Loeb scale, while Oumuamua and 3i Atlas have been identified as level 4 objects. So these are such objects for which we should not become afraid of such objects, but this scaling tells you that these objects cannot be explained in terms of simple physical explanations. So basically, we have like three objects so far, and two of them are on level 4. So that's something which is very interesting. And the Loeb scale, now, recently, in a paper, with Professor Loeb, we actually proposed something similar to, Carl Sagan's equation. So basically, Carl Sagan proposed this equation for for correlating the Kardashev scale with some mathematical formula. Uh, in the initial paper on the Loeb scale, similar to Kardashev, they had only proposed like a qualitative measure for like the various properties of the interstellar object, and at what scale it would be. uh, in my recent paper with Professor Loeb, we actually proposed like a full mathematical, very rigorous mathematical treatment as to how you can, basically using the parameters for the interstellar object that you have measured using observatories, applying all that into one mathematical framework will tell you at which lobe level any particular interstellar object is. And similar to 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 Carl Sagan's refinement of the Kardashev scale, our mathematical formula also gives a particularly smooth transition between the Loeb scale mappings the uh, and the mathematical stuff that we have suggested. So in our mathematical model as well, you have Borisov at level 0, Oumuamua at level 4, and 3i Atlas at level 4 as well. So that is consistent. So now how can we link these two things, because the Loeb scale and the Kardashev scale, they might seem different because one is talking about about one whole civilization, while the other one is just talking about one interstellar object. But they basically answer two sides of the same question. Who might be out there and how might we see them. So the who might be out there question really comes from the Kardashev scale, and the Loeb scale takes care of the second part of this question, which is how might we see them. So if there was some civilization which was very technologically advanced, of course that civilization which will try to probe other civilizations like we are trying to probe life on other planets or the other worlds. So similarly, with the Kardashev scale of a civilization increasing, they will also try to send out more and more interstellar objects. And so these objects to for the other solar systems, that will look like some kind of asteroids or something like that. But using the Loeb scale and given particular properties of such objects, we can then try to find out whether that object is something artificial, whether that is something we should be threatened by, or whether that is just something to try to monitor us. And in the future, both could possibly be mapped together into one framework. So basically, if you know there could be a framework where if you know the Kardashev scale, you can tell the Loeb scale of the object, or like what would be the Loeb scale of the objects that a certain civilization could send. Or if you know about the Loeb scale of an object, then you can tell about what would have been the Kardashev scale of the civilization which sent them. And that is very interesting because uh, in such a framework, by just analyzing one object and basically attesting to the fact that it was created in some artificial manner, you might be able to by just one object you would be able to quantify the extent or the powers of the civilization which created it. And that can be something which is very interesting, and that can be something which becomes very important with the amount of new stuff that we observe with regards to ISOs. And of course, there is another side of the coin. It might be possible that the ISOs are not at all about aliens, right? Those can just be very natural events. And I will just try to like share some reasons as to how such events might create these fast objects, these huge objects. So space is not quite right, and you might have heard about something known as supernova. So basically, when a very massive star, you know, explodes, it can eject trillions of tons of materials into space, and in some cases, that supernova can also lead to a black hole, or the or the other stuff, depending upon how massive the star really was. But the important point is it can eject trillions of tons of material into space, and these blasts can be seen as like fragments of like rock or metal, which comes at like speeds which are very fast, similar to the kind of speeds at which Oumuamua or 3 Atlas are at right now. So one reason that we observe such random rocks moving at such high speeds, being such massive, could be that those are because of some supernovas which have occurred nearby our solar system. But you know you can possibly explain about the mass, you can possibly explain about the speed, but like if the object has a very particular shape, well, in a random event, in a random explosion, you would not get a very particular shape in it, right? So if the shape looks very engineered, again, if its radiation capacity looks very engineered, in that case, you would still have to think about the theory that it might have been artificially created. Then it can also be because of young planetary systems. So giant planets can act like slingshots. Because of their gravity, they might eject comets or rocky bodies into space at a very high speed. So someone like Jupiter does it very easily. And there is also one theory that there was actually one extra planet between Jupiter and Mars, and that planet was like destroyed because of them both. uh, and now some of the asteroids that we see in our solar system, even to this day, are just the remnants of that destroyed planet. And so it can be possible that a single strong gravitational encounter can like accelerate an object to very fast speeds to leave the solar system forever. And to some other solar system, that might look like a very anomalous object. But again, you can explain the speed, you can explain the mass, but like in some cases, even the mass is like very huge. So even you cannot explain the mass. And even if you could explain the mass, it might become hard to explain you know uh, the shape of such objects if that shape is very anomalous to begin with. And there are also tidal disruption events. So basically, what does that mean? Well, by that we mean that if let's say if there is a planet which goes very very much near, like a black hole or a neutron star or some huge star which is not in its own solar system, or if a black hole, if a neutron star, if something like that, if some huge celestial body like that comes close to a planet, it can be possible that because of the sheer gravitational pull of that object, the planet might be destroyed, the planet might be ripped apart. And such things can happen near neutron stars and black holes, and they can rip apart planets completely. And of course, when such a violent event would occur, it would throw out pieces of like rock or like the other materials out into space at very enormous speeds. And so that could also be one reason as to why we observe such speedy objects. And they can then be very exotic possibilities, like supernova shocks. I mean, that's like very distinct events. There can be something like stellar jets. There can be I mean, then there can be some possibilities which are very theoretical, and so I would not like to go into the details of that. But basically, tidal disruption events and supernovas are usually assumed to be the big reasons why we observe very anomalous star clusters which might be giving these kinds of anomalous objects towards our solar system. So like we do not begin with the assumption that somebody created some object to like throw towards us. We do not usually begin with that assumption, but like sometimes we are led to that assumption because of the kind of physics that we observe of such objects. And so this can be the roadmap of ISOs, some can have artificial or origin. Of course, that can be a possibility, but then the big possibilities could be that they are possibly ejected from some planetary system because they were part of like a small planet which was destroyed by the bigger planets. They could be also created due to stellar explosions like supernovas or tidal disruption events. Basically, they might have had the misfortune of going very close to some to some neutron star or some black hole, and that might have been the reason why they would have been destroyed. But these can be like the big four origins stories for like most interstellar objects. There can be three ways to naturally create such objects: stellar explosions, tidal disruptions, and ejections from a planetary system, or they can be artificial origin. And so for the artificial origin bit, of course, you cannot be sure what kind of a artificial origin or like what kind of a truth was being constructed for such an object. So yeah. So finally, what can these objects really tell us? So firstly, they can tell us about how planets form around stars beyond our sun. It can be very helpful for understanding you know exoplanetary physics. Basically, possible habitable worlds beyond the Earth. If let's say 100 years from now, 200 years from now, we want to leave the Earth for some reason. Well, that can be our cue to actually do that, because uh, you know uh, you know these objects might tell us about possible habitable worlds beyond our planet. They can tell us about molecular compositions. They can tell us about materials which exist beyond our usually planetary system, and someday this might be used in space mining as well. uh, they can tell us about how powerful events like this, like supernovas, like tidal disruptions events, basically shape matter flow in the whole galaxy, and tell us about how galaxy as a whole inside, from the inside, how does it evolve with time. And of course, if we have some very high speed visitors, that could be a hint towards artificial origins, towards life beyond our planet. And this also tells us how our solar system, how our measly average solar system fits in the bigger story of the Milky Way, and possibly of the whole galactic cluster that we are a part of. But to end with, interstellar objects really just tell us, that we have so much more to learn about the universe, that we cannot even explain. Simple objects that randomly come into our solar system. You know, we struggle to explain even those objects. So like, sometimes if you might think that everything has been discovered in science, everything has been discovered in astrophysics, or what would I do, what would I understand, what would I contribute in. So you can just think about interstellar objects and be relieved that there is a lot of stuff that we don't understand, and we need your help in order to understand that. We need smart people like you to take up the reins, become scientists, and answer the questions that many don't even dare asking. And with that, I would once again like to thank the Nehru Planetarium. I would like to thank Rishabh for inviting me for this, and for Prerna ma'am as well for hosting this. And I leave you with this. I leave you with this. Just keep on asking questions about why you are here, and eventually, you will reach at some answer which might satisfy you. So, thank you so much.
Thank you so much, Om, for this captivating and thought-provoking talk. Your insight into interstellar object and has given us a new way to look at the cosmos and our place within it. We will now open the floor for some questions because people from the YouTube also have joined us and they have asked really nice questions. Just a minute. Yes. Super insightful discussion of what orbit and speed can tell us about deflection.
All right. So I'm not sure if that is a question, but I can take it as a question. So basically, that is actually a field which is being worked upon, right now itself. In fact, like last month, Professor Loeb and myself, put out a paper where we discussed, given the orbital parameters and the other dynamical, constraints that you have on a particular interstellar object, whether you can say, whether that object was, a just observed by a random chance, B, whether it was concentrated towards our solar system. So, was it projected towards our solar system? And C, whether, such objects can be observed later on by the Rubin Observatory as well. So, that is like a field which is being currently worked upon. And that is why I said towards the end of the talk, we don't really, of course, we don't have like much of a observational handle, much of a, astronomical handle as to how we should go about dealing with interstellar objects. But at the same time, there is also, the need for new theoretical frameworks to actually understand this thing. And so, new models are being worked upon by, people like myself and by others, and they are trying to understand, whether or not, we can understand these objects in a natural way or in an artificial way.
So this will take the new question, Anmol Gandhi. So for interstellar visitors like Oumuamua and Borisov, how do scientists determine and assign their official name? Is there a difference in the naming convention for asteroid, comet,
Yeah.
etc.?
All right. Yeah, that's a very good question. So with Oumuamua and Borisov, Oumuamua, as I mentioned, it is related strongly because, in its discovery, the observatory at Hawaii played a big role, and so the word, Oumuamua comes from Hawaiian traditions, and so, that's why it caught the wind very easily. And Borisov was, made. I'm I, I'm not really sure, which country discovered it, but I'm pretty sure, it was in, in like some place in Russia, or like, some place which was like previously in the Soviet Union. And so, mostly I would say that, physicists are like creative people, but like in terms of naming, we are not very creative. And so, we just give names which are like the most coolest. It is not like the IUPAC nomenclature that you have a particular, bonding system uh, for a molecule, and name it, like given, particular constraints, or like particular, ideas, or like a particular policy. People just name things in the way they find it cool these days.
Moving to the next question, Nandini Madhukar, what properties would make an interstellar object more likely to survive its long journey through interstellar space?
Right, great. An amazing question, and actually, the reason I say that, that's an amazing question, because one of uh, one of the new papers that, like, myself and Professor Loeb are working on self-powered spacecrafts. So basically, we are trying to see, could a spacecraft be powered by its own right, and if you have a self-powered spacecraft, how would you be able to, basically detect that using the Rubin Observatory? And so, I think one important, aspect, for like such objects would have to be that, of course, you would have to have like some kind of a, continual, inflow of energy. You need to make power on your own spacecraft for a long journey. So if you rely on other natural sources for like a very long journey, of course you will not go very far, like we saw in the case of, Jupiter, Jupiter, and and the and the journey of the Voyager spacecraft. And so, like continual, inflow of power is needed, and at the same time, you would also need, you know, uh, like a very good control of the spacecraft, because space is not empty. It is always filled with some kind of traffic. So if you want to keep on moving in space, you would have to maneuver your spacecraft in a way that you do not hit something else and just die off. So if you have some people on board, you need to ensure their safety as well. So you need to ensure the safety of the crew, and at the same time you need continual power on the spacecraft to keep on moving for a long time.
Yes. Then we have end of times could also be from extinct planet considering between 3 billion 6 billion years old. If prob or unknown cosmic background of new origin must be studied as much as possible. I know.
Well, that's an amazing question. I think I touched upon this thing slightly, because if you think about it, if we assume that the Voyager spacecraft is still out there in space and has not been destroyed by some other asteroid till now, and let's say some civilization like ours, like detects that, uh, you know uh, in their own time zone. So they would possibly think, like, let's say, if they were to like detect it 5,000 years from now. Well, w- what is to say that humanity has not been killed off by then? It could be a possibility, right? So for them, of course, if they were to term the Voyager spacecraft as some kind of intentional creation, well then yes, that will be coming from an extinct civilization. But the thing is, on that time scale, 3 billion, 6 billion years, when we say that something is like 3 billion years old, we just say that light from that thing is reaching us 3 billion uh, years later. So imagine this: if like there was a distance which light took 3 billion years to reach, then possibly uh, the second light from that thing is not going to be visible for the longest time. So possibly not billions of years, but like for sure, we can at least probe the idea whether such objects could have been created because of extinctions of some other civilizations. But like the time frame has to be slightly within our reach actually.
So I think in continuation, would also like to comment that lag NG is puzzling. Why we still have none?
I'm not sure what NGA is in this context actually.
So could interstellar comets are responsible for delivering unique isotopes and rare molecules to planetary systems?
Oh, yeah, 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 for sure, for sure. In fact, uh, like one idea w- which has been put forward by Professor Loeb himself in one of his recent papers is that it could be a possibility that 3A Atlas might release sub probes into the solar system, and if that is something artificial, that is. And so you know if if you want to release sub probes into the solar system, well, you might release some kind of isotopes which are not seen on this planet, or which might not be stable given our technological prowess. So yeah, it could possibly give us some kind of unique compositions which we don't really see on the earth very easily. Lack of non-gravitational acceleration. Yeah, yeah. I mean, yes. If like if you can basically confirm, and if you can basically prove that a particular object has a way stronger non-gravitational acceleration component than its random gravitational acceleration component, that is certainly one very strong indication towards artificial creation. But the other thing is, you can also explain the non-gravitational null part using some cataclysmic event. So it could be a possibility that there was some, again, as I mentioned, some huge supernova not very far from our solar system, and that could have been the reason why you know uh, like an object has like a huge non-random component of the acceleration. Tidal disruptions, planetary ejections, all of those are like valid reasons. But again, like if the if the non-gravitational acceleration has like orders and orders of magnitude, more significance in the motion of a spacecraft, in the motion of an object, rather than the gravitational part, then for sure it makes you think that something non-natural might have really been responsible for creating such an acceleration.
So I think with this we'll come to the end and we'll wrap this very captivating talk of today. Thank you once again, people who have joined through the YouTube live, and heartfelt thank you once again to Om for sharing their time, his knowledge, and passion with us. Event like this remind us why science is not just about discovery; it's about the curiosity, imagination, and shared human desire to explore the unknown. We would also like to thank the planetarium team and especially Rishabh for getting in touch with you and making this event possible. Not physically but online, and sometime in future we really hope to see you at the planetarium, and it will be in an absolutely pleasure for us to host you at the planetarium dome. With this we'll conclude today's webinar and looking forward to host you. Until then, stay curious and keep looking up star. Thank you once again for this wonderful day, everyone. Thank you,
Thank you
everyone.
so much. Thank you so much.
Thank you.